stereo perception. This is something very interesting because our perception of stereo, our ability to place a sound somewhere into space, is linked to phase. Not only, but also. But first we need to understand how sound propagates through space. At lower frequency, from 20 Hz to 700 Hz, something like that, give or take, the propagation is mostly spherical. Sound goes into all directions. This is why if you stand behind a speaker, you will hear low frequency. Even if it's playing low, mid and highs, you won't hear so many high frequencies. At higher frequencies, 7 upwards, sound starts to go very directional, straightforward. Lower frequencies go spherical and the wavelength is very long. Low frequency has the ability to easily walk around obstacles. While higher frequency, wavelength is very short, they are linear in the propagation, so they are easily blocked by obstacles. Now let's come to phase and how this plays a role. Our ears, they are usually spaced. Human head is between 17 and 18 centimeters. In terms of sound waves, this means that the length of a wave that takes this distance is around 1.9 kilohertz. If a sound comes to your ears and it's to your right side, it will come first to your right ear and it will take a bit longer to reach the left ear. It means that we will hear the same frequency, but with a difference in phase. Obviously, we can perceive phase differences going from 0 to 360 degrees, but as soon as the difference in time is longer than a full wavelength, we don't perceive it anymore. From 20 Hz to 150 Hz, no stereo perception. Of course, around 150 we start to be able to locate sounds into space, but at 20 Hz it's nearly impossible. From 150 Hz to 700 Hz, this is only due to phase difference. From 700 Hz to 1.5 kHz, interaural loudness difference starts to play a role because now we get sound that propagate more in a linear way, and so the head is working as a shadow. From 1.5 to 2 kHz, this is really the transition zone. Why? Because above 2 kHz, we are not able anymore to locate thanks to phase, and our localization is only happening thanks to loudness. So now we can understand why we use actually phase altering tools or delaying some sounds to create fake stereo because of our head. And also, this is why, for example, one of the most known mic couples to record stereo, which is called the ORTF couple, discovered by the French television, is using two microphones that have, give or take, 17 centimeters of distance and that are angled.